In this video, we'll talk about equations of perpendicular lines and how the equations relate to one another. So, similar to what we did for parallel lines, let's take a look at an example first to kind of try and motivate some thinking here. So what we have here in this equation is y equals 2x plus 1. It has a slope of 2, y-intercept of 1. And what I have done is I have made this line perpendicular to it. Now, the idea is we're trying to determine how these things are related. The idea is let's take a look at this line. In particular, let's look at its slope. So the y went down 1 and the x went over 2 to the right, which means that the slope of this line is negative 1/2. And if we're looking at negative 1/2 versus 2 and trying to discern some sort of relationship to that, and it should make sense that the slope there should be some kind of relationship there. All of these perpendicular lines should have same slope. If I create more and more perpendicular lines to this one line, y equals 2x plus 1, I should have the same slope for each. And it turns out that perpendicular lines have negative reciprocal slopes. So that might sound like a lot, and it might be a little terrifying hearing negative reciprocal. Those are big words. But if we think about this 2 and this negative 1/2 here, the reciprocal of 2 is 1/2, and then I just make it negative. Or I could think about it where I make the 2 negative and then create the reciprocal of that. So negative 2, which would be negative 1/2. So again, we can use this to our advantage to create equations very similar to parallel lines. We just have to bear in mind that perpendicular lines have negative reciprocal slopes, not same slopes as the lines that they're perpendicular to. So let's put this into practice. Let's say I'm trying to create an equation for a line that passes through the point negative 1, 7 and is perpendicular to y equals 4x plus 1. Now this tells me if I look at the slope of this line is 4, which means that the negative reciprocal of that would be negative 1/4. That is the slope of my new line. Okay, now again, we can apply two thoughts here. We can go with the slope-intercept method, where we could say y equals negative 1/4 x plus b, plug in our points, and we could say 7 is equal to negative 1/4 times negative 1 plus b, which means that b is equal to, looks to be 6 3/4 if I subtract off the 1/4 from both sides. So then my equation would be y equals negative 1/4 x plus 6 3/4. And that sounds a little gnarly, but it's an equation. It works. And that would be one option that we have. Now the other option is we can jump straight to an equation using point-slope form. So we could say, using our points, which is negative 1 and positive 7, so we can essentially say, all right, y minus y1, which in this case is 7, is equal to negative 1/4 times x minus a negative 1. Again, just using the point-slope method, we can simplify a little bit. So we can say this is y minus 7 is equal to negative 1/4 times x plus 1. And both of these have the same meaning, and both of these are equivalent to this equation we have down here in blue, this slope-intercept form. You have your choice. You can pick which method you like. And both equations, or I guess in this case all three equations, have the same meaning. They would have the same graph. They'd go through the same points. So perpendicular lines, the key takeaway here is that they have negative reciprocal slopes. So make it the reciprocal and make it negative, or make it negative then apply it to be a reciprocal. Either way, it'll get you there.